In this video, we're going to talk about these three questions, 2, 3, 7 in chapter 2. I have number 10, 12, 16, 17 listed in chapter 2, but you don't have to do it this week. These will be next week's assignment. Number 2, indicate whether of the following statements are true or false. Justify your answers. For each statement here, first you determine if it's true or false. As we talked about before, statement is either true or false. Secondly, if it's true, I don't need you to justify it. If it's false, give me a counterexample explaining why this is false. So for example, part A, every integer is a real number. If you know the definition of integer and real number, and you can determine if it's true or false. Integer is numbers such as 1, 2, 3, 4, 5, and so on, or go down 0, -1, -2, -3, -4, and so on. So that these are integers. Real number is basically any number you can think of, unless you know imaginary number, complex numbers. So any number that is not real is called imaginary. But in real life, in most of math classes, you will only talk about real numbers such as square root of 2, which is also a real number, and pi, that's also a real number, and fractions, 1/3, that's also a real number. So any number you can think of is a real number. Part C, for all real numbers, R is a negative real number. By the way, so you will use the definition, what numbers are integers, what numbers are real numbers, and use these to determine if A is true or not. For C, it says for any real number R here represents a certain real number. And a real number, like I said, it could be any number. It could be positive, negative, or 0. And for example, 1/2 is a real number, and -3 is also a real number. 0 is also a real number. So here, first you determine if the sentence is true. What it says is R is a real number. Negative R means you put a minus sign in front of this number, and do you always end up with a negative real number? And if you say yes, I don't need you to prove it, but if you say no, you need to give me a real number and show me that when after you put a negative sign in front of this number, the number you picked, you won't get a negative number. Okay, so that's how you do A and C. So these are just some questions, the basic questions. It's nothing new. It just you use what you know in math, and to determine if these statements are true or false. Number 3, let P of x be the predicate x greater than 1 of x. X here is a number, and any number, and usually you can see x shouldn't be 0, because if x is 0, 1 over 0 is undefined. So when we pick numbers, we shouldn't pick a 0 for x. Now, like we said before, we like to use symbols to represent any statement. So x is greater than 1 of x, we can use the statement, we call this inequality P of x. Okay, so what is P of 2? So I can do, say, for example, P of 3. Let's write down the statement. X is greater than 1 over x. And so this statement here is called P parenthesis x. Okay, now what is P of 3? That means from algebra class we have learned function. So this 3 inside means that this x. Okay, and what is P of x? P of x is a number. P of x is this inequality. X is greater than 1 over x. So P of 3 basically it's when you replace x, it's 3 greater than 1 over 3. So after you replace x with the number 3, and that's P of 3. So similarly, we can do P of 1/3, and x, the left side is x, so x is 1/3 now, and greater than, the right side is 1 over x. 1 over something means the reciprocal. Reciprocal means you flip the number you have. So the right side, you will have to flip the number x, which is 1/3 in this case. When you flip 1/3, you get 3 over 1. Okay, so that's what P of 3, what P of 1 of 3 is. Whatever the number inside, you just plug into the statement, the inequality, and determine. Next, you determine if it's true or false. The first one, P of 3, apparently 3 is greater than 1/3, so I call it true. The second one, 1/3 is not greater than 3 over 1, so that's a false statement. So this is how we do the question number 3 here. Okay, so similarly, you can do the other numbers even if they are negative numbers. That's part A. Part B, find the truth set of P of x. And the truth set means all the you need to find all the numbers for x such that the inequality is true. So for example, right here I found one number 3. So this number 3 should be in the truth set. So truth set 3 will be in there. But 3 is not the only number. I know 1/3 is not in there, but what about 4? And if you do a quick check, you will find out 4 is also greater than 1/4. So 4 should also be in there. Even 3.5 should also be in there. So by plugging some numbers, positive numbers, negative numbers, fractions, and you will find out that what kind of numbers will make this inequality true. So that's called truth set. And well, you have to find all of them, not just to give a list to say 3 is, 4 is in there, 5 is in there, because it's not just a few numbers, it's a lot of actually infinite many numbers. So you will need to tell me what numbers you pick for x, you will get a true statement for x greater than 1 of x. So it should be too difficult after you plug in some numbers there to check. So you will figure out a pattern. So the numbers bigger than 1, less than 1, or negative, positive. So that would tell you what the answer is. Okay, so that's how you do part B, the truth set. So what truth set means, all the x values. So remember, truth set is for x values. The numbers you will pick for x such that this statement, x greater than 1 of x, is a true statement. Okay, the part C, if the domain is R plus means all positive real numbers, so you won't need to consider negative ones. And what is the truth set? So for part B, when you determine a truth set, you have to pick not only positive but also negative numbers. But when you do C, you don't need to worry about negative numbers, so you only look for the truth set in the real numbers set. So you will pick 2, 1/2, or so on, and to determine if any positive number, what kind of positive numbers will be in the truth set. So in other words, what kind of positive numbers you will pick for x such that x is greater than 1 over x. So that's how you do part 3. Part 7, find the truth set of each predicate. So in number 3, the statement is x greater than 1 over x. But we could have other cases. For example, 6 over d is an integer. And we know that 6 over d may not always be an integer. For example, if we, let me give you, let's see. Now, 6 over d, we want to make 6 over d an integer, and we just talk about the definition of integer. Integer is a number like 1, 2, 3, 4, or 0, or -1, -2, -3, -4. D here, it represents, any letter represents a variable which can change. So if I pick 4 for D, suppose D is 4, and I plug it in, I will get 6/4. 6 over D will become 6/4, and which can be simplified as 3/2. Apparently, 3/2 is not an integer, it's a fraction. So D4 is not in the truth set. What if I pick, say, 3? If I pick 3, 6/3 is 2. That is an integer. So this one is false, and this one is true. So 2, not 2. I'm sorry, 3. When we look for a truth set, it's for the variable in the statement. So this D, what's the truth set for D? So that would be because 3 will make 6/D an integer. So 3 is in the truth set. So you have to keep doing this. Not only I pick some positive, you can also pick some negative. Even if I pick -3, again -2, which is also negative a whole integer. So -3 is should also be in the truth set. So keep doing this, try to pick some positive numbers, negative numbers, and you will find out what kind of numbers you should pick for D to make 6/D an integer. So that's what you are looking for. Now that's part B. Part C, predicate 1 is less than or equal to x squared, less than or equal to 4. So we're looking for the numbers we pick for x such that x squared is between 1 and 4. Okay, so let's do this one here. So we have the statement y is less than or equal to x squared, less than or equal to 4. So let me just randomly pick a number. So what you need to do for all these questions, just randomly pick a number and plug it in and see if it's true or false. Usually when you pick the numbers, make it diverse, so positives, negatives, or fractions, and so usually we'll figure out a pattern after you try a few. So let's pick I'm gonna pick 1. If I pick 1, what's x squared? Then in the middle, x is the one that changes. So I replace x with 1, I get 1 squared, which is still 1. So the answer for x squared is 1. Is 1 between 1 and 4? Of course it is, because there's an equal sign here. So this will be true. That means 1 should be in the truth set. And you can check 2. Apparently 2 is also there. What about so we get 4, and 4 of course is between 1 and 4. But 1 and 2, they are not the only two numbers, because we're talking about real numbers, and the real numbers should be, so here it's not talking about integers, here we're talking about real numbers. For part B, you only need to pick positive integers, because here it specifies positive integers. So when you pick numbers for D, just pick integers. But part 3, they are saying real numbers, so you need to pick fractions too. Part C, it says all real numbers, so you have to also pick some fractions. So I picked 1 and 2, so you can try to pick some fractions, 1/2, or even negatives. I didn't pick negative, and you should also try -1 and a -2, -3, or +1, -1/2, and to plug it in to see if it's true or false. And that would determine that will help you to determine what numbers we should pick for x, which will make x squared between 1 and 4. So that those numbers will be in the truth set. Okay, so that's how you do these questions, these 3 questions here.